A lot of things claim to be easy. Easy as pie, right? But have you tried baking a pie from scratch lately? There's a whole lot to mess up. Trust me, undercooked pie dough can have all sorts of negative repercussions, including but not limited to never being able to host Thanksgiving again. Yeah, moving on. Easy as 1, 2, 3. Sure, but once you get past about 3.14159265535, it starts to get pretty irrational. Now, this is certainly true with our IoT development kits these days. I don't know about you, but I want super easy, from late night brainstorm all the way to handing a prototype to my boss the next day. Why, yes, this is my idea. Oh, you think I should move into the corner office right away? And yes, I would love some coffee. Thank you. I'm sure it'll go down exactly like that. Hi, I'm Amelia Dalton, host of Chalk Talk, and yes, we are talking about an easy peasy IoT development kit today that is not only simple to navigate, but makes reprogramming a snap, mobile and cloud apps a breeze, and connectivity a piece of cake. Or pie, as the case may be. Please welcome Jay Canteenwala from NXP to Chalk Talk. And yes, he is bringing us the goods on the NXP Rapid IoT Prototyping Kit. And did I mention it's going to be easy? Okay, maybe I covered that. Cool. Let's go. And before we get started, don't forget to click that link. There you can find more information about the NXP Rapid IoT Prototyping Kit. Hi, Jay. Thank you so much for joining me.
Hi, how are you, Amelia? So good to see you.
That's good to see you too. Okay, Jay, so we're here to talk about the Rapid IoT Prototyping Kit. But before we get started, I believe you have a cool video to show me of this in action?
Yes, we absolutely do. We actually have several cool videos, but let's just start with this one. A video is worth 1,000 words, as they say. So let's just play it right now.
Meet Jerry. Jerry likes to get things done. Even as a child, Jerry's always acted on his ideas. Here's the thing with ideas. Ideas aren't always easy to bring to life and take to market on time and under budget. What if something could bridge the gap? Something simple, something powerful, something fast. It's time to let Jerry quickly develop and share his ideas with the world. Introducing the Rapid IoT Prototyping Kit. It's comprehensive, expandable, easy to use, designed to accelerate the prototyping process for IoT end nodes, so you can focus on being creative and developing your IoT idea. In this fast-changing world, winning requires a great idea and being the first to bring it to life. What will you build? The Rapid IoT Prototyping Kit, available now.
Okay, Jay, that was super cool. Now, what's all included with this kit?
All right, excellent. Before we jump into that, let me give you a little preamble to that. So, as we saw, ideas are powerful, but bringing them into production is a whole different concept, right? A whole different task. And the Rapid IoT is intended to lower this barrier of entry and democratize IoT, essentially. Let's step back and think about why we designed it. It's obviously to help people, like we saw in the previous video. And by the way, and for full disclosure, that kid is not a younger version of me. That is simply an actor.
Okay, good to know.
All right. So what is the Rapid IoT Prototyping Kit? Well, we looked at what somebody would need to make an IoT node, and we tried to trim it down to the most useful pieces and help them from every step of selecting the components to doing the software and connecting up to the cloud. So the first thing is that it's a very comprehensive node. It combines over 20 devices. And if you look at what is commonly found in an IoT application, you'd have to have some kind of sensing that would go to some processing. You'd have to have connectivity. If you do it right, you have to have security built in at the beginning. And then you have to have a way of communicating all that information. So we've packed that in a very small form factor package the size of a man's wristwatch. The software enablement is an important piece. So imagine having to write the drivers and the RTOS, put together the middleware for all those hardware pieces. You don't have to do that. We've taken care of that. It's seamless. If you want to expand to a sensor that we don't offer, there is a path to do that as well through different clickboards. There's over 400 of them today. Now, after you've taken care of the hardware, the most important part next, and perhaps the most time consuming, is writing the software. So that's where the accelerating IoT design comes in on the upper left-hand corner of the slide. What we have is a web IDE, which means you don't have to download it. You can access it from wherever. It's on the web.
Okay.
And it's got a drag and drop based programming. So in other words, it's really easy to use. If you do want to take your project into production, then it imports all the code that you develop imports into MCU Expresso, which is the NXP IDE, and it gives you the checks and balances that are provided by a very robust IDE, which is MCU Expresso. So that lets you take your prototype to development, should you want to do that. The next piece, which is very important, is that it's secure. We built it in being NXP. It's got a secure element. It's got secure authentication. You can have a secure boot for reprogramming, and it's got different crypto accelerators. So we built this in from the get-go rather than as an afterthought.
Nice.
And then finally, you want to get this information from the Rapid IoT out, usually into a mobile device.
Yeah.
So we took care of that. There's a seamless connectivity to your Android or iOS applications, and from there to the cloud. So bottom line is, we really tried to make taking your IoT idea to a POC as easy as we like to say, 1, 2, 3.
Okay, Jay, so what does this Rapid IoT kit really look like? Can you show me what's all under the hood?
Oh, absolutely. So let's take a look at one of our favorite slides, which is the block diagram. And you can see here that it has over 20 devices, 11 of which are from NXP. So we selected the best of breed, lowest power, lowest cost. And when we didn't have it, we used a third-party device.
Okay.
Yeah, the intention really was to provide a node that would be helpful, not just one that had NXP devices in it.
Okay.
Yeah. Everything in green is an NXP device. You can see we have the main MCU, which is the Kinetis K64. That's an ARM M4 Cortex. We have a separate wireless MCU, which has BLE, Thread, and in future Zigbee. You can see analog sprinkled throughout. There's a power switch, a battery charger, more power switches, several I2C switches. And then we can get into the different sensors. So you can see we have a combo accelerometer, magnetometer, a gyro, barometer and temp sensor. And then we can get to some other sensors, which is we have capacitive touch. So you can imagine you might want that in the future, the same technology as you use when you tap your credit card. It does a handshake and acknowledges that you have the authenticated correct device.
Sure.
The most common would be a humidity and temperature sensor, an ambient light sensor. You can imagine that being helpful if you want to detect any motion in a room or any other presence. And one of my favorites is the digital air quality sensor, which is becoming very relevant, not just in other parts of the world, but even here.
Sure.
So it's got a lot packed into it, all, as I said, the size of a gentleman's watch. And it has a color display as well.
Nice. Okay, so now I can imagine that this kit would be really useful for a lot of different applications, but what kinds of stuff have you seen, Jay?
Yeah, so this has been a tough one to answer, really, because we start off with what we think are the use cases, and then we find out use cases that we hadn't thought of. So that's perhaps the most fun part of this project.
Sure.
If I were to just summarize it, I'd say, think of something that needs to be low power.
Okay.
You have to have security built in. You, of course, need sensing.
Yeah.
You need processing, and it needs to be cloud connected, which pretty much covers almost everything.
Yeah.
But given the kind of sensors we have and where we have seen interest is in home and building automation and in the adjacent smart cities and industrial applications. Now, in industrial is interesting. We've seen interest from asset tracking. So people want to manage and track their asset, figure out if there's been a fall and the asset has been damaged, let's say in shipment. They want to know exactly when that's happened.
Yeah.
There's different applications that have to do with health and wearables. And the most interesting is the use cases that we haven't discovered yet, which has got this little futuristic drone flying around. But someone at NXP has actually taken the Rapid IoT and mounted it on a drone, and they're flying it around to take different measurements.
Nice.
We've had people create projects for smart agricultural applications, and that's not even something that we envisioned when we started this. So think of what you want to do. If it's low power and it needs those other factors, it might be a good fit for you.
Cool. Okay, Jay, let's talk specifically about the I of the IoT here. What kind of connectivity options does this kit give me?
So right out of the box, the Rapid IoT connects over BLE to your phone.
Okay.
Now, this is really simple. On your phone, you just go to either the Apple Store or the Google Store, and you download the Rapid IoT application, and presto, your connection is set up.
Nice.
From there, your phone will connect up to Atmosphere Cloud, and you have the option of using Atmosphere Cloud or other clouds.
Okay.
Another way to connect is over Thread, which is the block in the middle.
Yeah.
So you connect over Thread to a gateway. In this case, I put the NXP Modular IoT gateway, but it could be a different gateway.
Okay.
And then from that gateway, with MQTT commands, you can connect up to different flavors of AWS.
Okay.
For cloud options. And then going forward, we have the most obvious. We have through clickboards the ability to have Wi-Fi connectivity as well as cellular connectivity. And there's many other connectivity options that we envision going forward.
Cool. Okay. So, Jay, what if there's a sensor I need, or I need a different connectivity option that isn't included in the Rapid IoT kit? What are my options here?
That's, again, a good question. And because IoT is such a broad area, it's practically impossible to cover every possible scenario.
Right.
It's just not going to happen. And it's very likely you might need a sensor that we don't offer. Let's say you want to do GPS and you want location detection. Well, then what you can do is mount the Rapid IoT on a docking station. And there is an ecosystem of clickboards made by Mikro Elektronika. There's over 400 of them right now.
Wow.
And it's an open standard connector, 16-pin connector. So the clickboards that you see in the picture mount on the different leaves of the docking station.
Ah, okay.
So let's say you get a GPS click mounted on that. And if we already support the driver, then it's as simple as literally putting it on there and making a connection. Or you can write the drivers for it.
Okay.
This gives you a lot of headroom, as you might imagine.
Absolutely. Okay, Jay, this hardware is great, but what is the software story here? And what's my IDE look like for this bad boy?
Yeah, so that actually is a really cool part of this. Now, our software, our IDE, is called Rapid IoT Studio. And the first thing about it is it's web-based, as I mentioned earlier. So it's accessible from wherever you are, right? You don't have to download anything. It's simply create an account on NXP.
Okay.
And you'll have access to the studio. So this is a visual drag and drop graphical user interface. And really, you don't need to write code in C if you don't want to.
Okay.
Right? So it's got a very robust library with different building blocks. So that means you don't have to worry about different SDKs, about APIs, about things playing nice with each other. Everything is set up for you. Let's say you want to add a certain sensor. I'll show you later. You simply click on it. The sensor appears there. You make a connection. And that's it.
Nice.
Yeah, and the coolest part about it is you can create at the same time, simultaneously, an embedded application, a mobile application, and the web application.
Nice.
So you get all that from start to finish when you complete a project. Now, the nice thing about this is that you don't really need to be a heavy-duty programmer to use it. If you are, that's great, right? It'll save you time.
Yeah.
And let's say you're an engineer working in a large company and you want to show your boss an idea, but you just don't have the time to do it.
Yeah.
It gives you an option of doing this.
Cool. Okay. Okay, so I think I understand the new project part, but Jay, on this slide here, it shows there's an import project.
Okay. Yeah, so with the import project, what that means is, let's say someone else has created a project.
Okay.
And you want to use that as a starting point. So they say, all right, Amelia, here's my project. What you do is they send it to you and you import it using this button. So now you have a starting point.
Ah.
In other words, you can share work, you can co-work, you can build on someone else's work.
Excellent. Okay. So, Jay, do I need to reinvent the wheel every time? Do I have to start from scratch every time?
No. You can, of course, start a new project if you want. But what I suggest is take a look under examples at different projects that we have already created.
Okay.
And the list keeps growing. So let's say you could see the classic blinking and LED example.
Yeah.
Well, it's right there. You just take that, and if you want to add to that, you can. If you want to now control that LED over BLE, all that code has already been generated. The application has been created for you,
Nice.
including some pretty complex applications. So you can have that as a starting point, modify it.
Okay. So you mentioned I can create mobile apps and cloud apps, but how exactly do I do that?
Yeah. So as you can see on the top bar of the IDE, there's 3 blocks. There's on the upper left, looks like a chip. There's the embedded app side. So when you click that, it takes you into the view where you created an embedded app.
Okay.
And so forth. So then you go into the mobile app. So that's for your phone or your tablet. And then there's the cloud app.
Okay.
The big space that you see in the center is what we call the canvas or the work area. That's our terminology.
Okay.
Then you can see there's some output controls on the upper right. The one that looks like a chip with an arrow pointing down is to download your binary code.
Okay.
The other one is to generate your output in your source code and take that with you. So whatever you create, you take with you. It's yours. On the upper right are the project controls. These are pretty obvious. You have the save and then the hammer for the compile.
Yeah.
And on the right-hand side of the vertical bar, you have the different elements that are available. So you could see on the canvas, for instance, they have a touch button on the left, or they have a Bluetooth on or off. It's as simple as selecting the element from the toolbox, and it'll appear in your canvas.
Cool. Okay. So I'm curious about that elements part. Can you show me an example of what that can do?
Sure. So the way you start a project with a blank canvas, obviously, is that you start by selecting your element. So let's
Okay.
say you want to select, in this case, we have a function. So you simply select the function button, and that'll show up in your work area. So what is an element? Well, the element has its own source code. It has its own properties and triggers. So you can see here when I select an interval element, on the right, you can see that the different triggers are selected. In this case, it's been set to trigger every 1,000 milliseconds, which is every second. You can modify that.
Yeah.
And then you can just go on and add so on and so forth. Now to this interval element, you can add a sensor and say, okay, take a sensor reading every second. That's how it works.
Okay.
And the way you connect them, it's pretty intuitive. You simply hover your mouse near an element, you get a 2-headed arrow, and then when it appears, you drag and drop it. In this case, we connected it to an LED. And it's interesting that the connectors also have their own source code and properties. So in other words, that connector is set so it knows where to go to that RGB LED chip and what pin to read exactly. So all that is done for you.
Nice. Okay. So let's say I don't want to use the elements and I usually write my own code. What would I do then?
Okay. Well, that's pretty simple. We do generate all the source code when you add an element, right? Now, let's say you want to modify what was generated for you and you add in your secret sauce.
Yeah.
So what you do is you click down on the icon on the lower right, which is the arrows going to the 2 sides, and a window will open up, which actually shows you the C code.
Cool.
And you can
okay.
go right in there and modify the C code.
Nice. Now, I built the application, but maybe I want to reprogram it. Jay, where do I go from here?
Yeah. Now that's the next step. So you built it, you save it, you compile it, and all
Right.
that, right? And now you want to download it down into your Rapid IoT to see
Yeah.
if it works. So you go to that arrow and chip icon on the upper right, plug your Rapid IoT into your laptop with a USB. You push a few buttons, that's explained later, and then it'll just program
Cool.
it. And a bunch of lights will flash, and your Rapid IoT will be now programmed with your new software.
I love it. Okay, so Jay, what about the mobile app part?
Yeah, now that's a really interesting part. So after you're done with the embedded part, the next step obviously would be to look at your output on a mobile device, right?
Right.
And you go to the application, the selector, and you can see when you do that, it opens up a screen on your left, which you can select to the format of your phone. So I have an iPhone 6S. So I just simply select this drop down, or if you have whatever other phone you have,
Yeah.
and it'll format the output automatically to the phone.
Cool.
Now, let's say you want to pretty it up and you want to put a picture of, I don't know, your kids in here or something.
Yeah.
Well, you can do that too. You select an image that you have saved and you drop it right into the mobile app. So you have the ability to customize it as well.
Very cool. Okay, so what about connecting to the cloud?
Well, that's interesting. When you're doing your application and creating it, you select a cloud element, and that means that your output is going to go to the cloud.
Yeah.
Right? So you simply select the cloud element from the toolbox and then move on to the next selector, which is the cloud selector. And you can see it has a cloud element already programmed in there. You select storage and you're done.
Nice.
Right? You're done. You can see the different AWS options on the upper right. And there's different cloud logic that you can use as well.
Okay, cool. So, what about the information collection? How do I dig into the data?
That's right. So now the information's in the cloud, but how do you really know it's there?
Right.
And what is that information? So when you move on, you could see that on this dial on the left of the dashboard, which looks like a meter or a speedometer or something, that opens up different selections on how you could look at your data.
Okay.
Right? So a pop-up opens up and you could do a data glance, you can do a meter. I like the data graph. It's just easy to follow.
Yeah.
So what you do is you select the graph and you configure it, and the data that you've been collecting will now show up on the graph. So let's say you want to connect BLE, you want to collect, light data,
Okay.
ambient light data, and then you want to look at it over time and see how it's changed. Well, if you set up the program correctly, it's simply going to go from the Rapid IoT over BLE to your mobile device and from there to the cloud. And you stored it in the cloud. Now you can go back and with these reports, you can view it
Nice.
and see how it changed. It is pretty amazing.
All right, this has been super cool, Jay. So I'm ready to get started. I'm going to click that link and go to Mouser.com. What all am I going to find there? What kind of resources have you got for me?
Okay, well, we're building on our resources. We have lots of really cool videos on getting started. So with Get Started, you get different options, starting from plug it in to download your software, how you build and run an application, how you create it, and then if you really want to get down into it, how do you learn even more and modify the applications.
Excellent. Well, I'm going to do that right now. This was super cool, Jay. Thank you so much for joining me.
Yeah, thank you. Appreciate your time. This was great.
And before we go, you didn't forget to click that link, did you? There you can find even more information about the Rapid IoT Prototyping Kit from NXP. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. Can't miss it, right across the top. Or head on over to YouTube. Keyword EE Journal.